We use AI tools literally every single day now, and honestly, it can feel a little bit like magic. But today, we are pulling back the curtain on that illusion. We're going to completely demystify the true mechanical architecture behind systems like ChatGPT and uncover the genuinely fascinating math that's running under the hood.
So how does ChatGPT actually work? Look, whether you're using it to write some complex Python script, debug your server configurations, or just summarize a massive PDF you don't want to read, it's so easy to get lulled into feeling like there's an actual human on the other end of the line. The responses just flow so naturally, right? You completely forget what you're interacting with.
Okay, let's dive into this. Because that human-like output creates a super pervasive myth, the idea that the AI is somehow thinking its way through your problem. The reality? It is purely mathematical. At its core, ChatGPT isn't reasoning at all. It is just a highly sophisticated prediction engine. It doesn't understand the world emotionally. It literally just calculates the statistical probability of which word comes next. To picture this, think about your phone keyboard for a second. You know that autocomplete feature that guesses your next word based on how you normally text? ChatGPT is essentially doing that exact same thing. It's just next word prediction, but on an unimaginably massive, multidimensional scale. It looks at the context of your entire prompt, calculates the absolute optimal next sequence, and does it over and over again.
Now, what separates a massive large language model from your phone's keyboard is pure scale. We are talking billions upon billions of parameters here. These models have basically ingested the entire public internet. Wikipedia, millions of books, GitHub repos, scientific papers, the whole shebang. By crunching all of that data, the system successfully maps out the deep, hidden structural patterns of human language.
But because it's fundamentally just predicting text, it's missing a few absolutely crucial things we usually associate with human communication. It has exactly zero real-world factual knowledge, no consciousness, no personal opinions whatsoever. It doesn't actually know what it's saying to you. It only knows the math, the probability that certain words belong together in whatever context you gave it.
And that purely statistical approach, that is exactly what leads to AI hallucinations. This happens when the AI generates a response that sounds totally logical and confident, but is actually completely fabricated. It's basically the ultimate confident bluffer in a corporate meeting. You know the type. They have absolutely no idea what they're talking about, but they string the right buzzwords together so smoothly that everyone in the room just nods along.
So the crucial point is, its goal is not truth. Its goal is prediction. When an AI hallucinates, it isn't lying to you maliciously. It's not trying to deceive you. It's simply experiencing a highly convincing glitch in its mathematical model. It's generating a sequence of words that statistically looks perfect, even if it's completely absurd in the real world.
To really wrap our heads around this mechanical process, we got to talk about tokens. See, AI doesn't read words the way you and I do. It breaks language down into tokens. These are basically chunks of characters, syllables, or punctuation marks that it can process mathematically. So a single word might be just one token, or the system might slice it up into 3 totally different mathematical representations.
Let's move to and see how this builds into the actual process. It all boils down to this relentless, high-speed loop. First, the system breaks your prompt into tokens. Second, it crunches that math through its massive network. Third, it predicts the very next token. And then, it repeats, over and over at lightning speed, predicting and generating one token at a time. It's like building a bridge right as you're walking on it.
Now, getting an AI to this crazy level of accuracy requires some seriously staggering resources. We're talking massive server farms, thousands of specialized GPUs working in tandem, and energy consumption that literally rivals small cities. And that's just to process the initial training data. It is a hugely resource-intensive undertaking to build this engine long before you ever type in your first prompt.
Now, what's really interesting about this slide is how that architectural feat is actually accomplished. It's done through deep learning. By using neural networks, which are these dense layers of mathematical nodes loosely inspired by the human brain, the system can map out incredibly complex, multi-layered relationships between all those tokens we talked about. The bigger the model, the more complex the patterns it can absorb and seamlessly replicate.
And boom, here is where the magic comes back. Because these models are so incredibly vast, simple next token prediction suddenly unlocks some amazing capabilities. Translating languages, writing code, summarizing a dense 50-page document, these aren't separate, dedicated programs running in the background. They're all just emergent properties of an engine that has learned how to predict the next word perfectly.
But of course, those same emergent properties come with real mechanical limitations. Placing blind trust in this stuff is super dangerous.
These models will confidently invent facts, they'll completely stumble over subtle context, and they naturally reflect the biases hidden inside their massive training data. And remember, these aren't moral failings. They're just functional constraints of a system built to calculate probability rather than verify actual facts.
And because we are now plugging these systems directly into high-stakes areas like healthcare, business analytics, and software development, those technical limitations elevate into major societal risks. Suddenly, accuracy, privacy, and cybersecurity are completely on the line. When we start relying on a prediction engine for critical infrastructure, verifying the output isn't just a good idea, it becomes an absolute necessity.
Because we have to remember, this isn't just a slightly better search engine. Past technology basically analyzed data that already existed out there. You run a query, it finds a match. Simple. Generative AI is creating entirely net new realities from scratch. Text, images, code, stuff that literally never existed before you hit enter. We've shifted from merely indexing the digital world to generating brand new parts of it on demand.
And this brilliantly illustrates why this shift from analyzing to generating is upending almost every single industry all at once. It's rewriting the rules for software development, disrupting marketing, and even altering how we communicate with each other in professional settings. It's a complete foundational change in how we interact with computers.
I really love this quote from Maya at Privacy Club because it captures the dual nature of this moment perfectly. She says, AI is incredibly powerful, but understanding its limitations may be just as important as understanding its capabilities. As we start baking these tools into our daily workflows, keeping a clear, realistic view of both their immense power and their inherent mathematical flaws is for sure the way forward.
So, we really are at the very beginning of this huge technological leap. The illusionist trick has been revealed, you've seen the math behind the curtain, but the big question remains. As society navigates these very early stages, are we truly prepared to use generative AI responsibly? Keep questioning those outputs, keep digging into how things work, and I'll catch you on the next explainer.